Hello. In this session, we will discuss about the LaTeX itself. In the previous sessions, we have discussed about how to write the technical documents, how to write the papers, and what are the templates which are generally used, some do's and don'ts while organizing your contents. However, I already said, instead of using Microsoft Office tools, can we use open source tools for the same purpose? Because we have some, being a technical documents, we have some advantages. So let us understand what is LaTeX commands. LaTeX is a language. By using this language, these commands, we can convert our documents into various file formats. It's a open source. Quick commands I already described while explaining the templates, but still, whenever we start the document, right, at the beginning of the document, we always say document class. And in square bracket, we give the options and the classes. So the document classes are, we have seen article, we have seen reports, we will see very soon slides, and also the conference and journal papers. We have seen the difference. If it is an article, how the paper will appear. It may have some sections, but however, if it is a report, then it will have chapters. And IEEE transactions means there is a style which you have to download from the repositories. It will create the double column, single column, and the standard way of citing their references. So at the beginning of your document, you have to tell the attributes of your document. The packages you have seen, we have included in the document. External libraries, we say use package is a command. For citation of the papers, the package should be cite. If you want to include the figures, then graphics, subfigures, math symbols, arrays, standard dimensions. So everything is a package. If you include those packages, then you can use those commands, right? You can use those functions. So package is also one type of a command. While writing the equations, we have a separate begin equation and end equation, because we are using some math symbols. However, as a part of the text, if you want to include the equations, then you can always put it between the two dollar symbols. Then you can start using the math symbols. Otherwise, the basic way of including the equation is begin equation, end equation. Between these two commands, you can write your equation with math symbols. You can also have a label. You can give some name to the label. The purpose of giving a label is it will assign the number to the equation, so that this label you can refer in the text. So you don't need to give the number. The label is replaced by some number. If you want to reduce or increase the space between the equations, then you can also say H space, right? Horizontal space, if you want to add between two mathematical expressions symbols, then you say H space. H space can be positive also, or H space can be negative also. If you give minus symbol in the existing space, it will try to reduce if there is any space exist. Or if you want to increase the space, then you give positive number. We have seen the equation, but if you have multiple equations, right, then no array of equations, it is better to use some commands for multiple equations. Like for example, begin equation array, end equation array, because you have more than one equation. And if you want to give different labels to different equations, no problem. You can give label array 1, array 2, something like that. That's okay. But multiple equations, if you want to club them together, then you say begin equation array and end equation array. There is also another form of multi-line equations with H space command, right? We called as a begin equation, begin split, then give the space with and symbol, and end split and equation. This way also you can create a multiple equations with one single label is possible, called array of equation, which we have seen in my previous examples. Inserting the figures, you can insert various JPEG, EPS files, PDF files, right? These external images can be inserted into your text file, including encapsulated PostScript file, EPS files. The commands for this is called begin figure, end figure. In between, you can give some attributes. Say for example, in square bracket, the attributes are HTB, right? HTB will say something about that figure. H means you want that figure to be here. T means top of your page. B means bottom of the page. It is your choice. Where do you want to place your figure? If you want the figure to be center of that page, center of that column, then say centering. And include graphics. Here you have to give the name of the file in this curly bracket, but you also need to mention the dimensions of the figure, because that will scale it. Height and width you are supposed to give. And of course, there should be some caption, self-explanatory about that figure. And label is always talks about that, right? Giving some number so that you can discuss about that figure in the text. You are not supposed to discuss in the caption about the figure or comparing about the results in the caption. That discussion you do it in the text by referring that label, and you don't need to give the number to label. It will replace that caption. And end of the figure. So where to place the figure? The attributes will tell H means here, T for top, B for bottom of your page. But if you give a exclamation symbol like H exclamation T, that means not here, not on the top. So opposite case you are saying by giving this exclamation symbol as a part of the attribute, not be placed here, like that you are extensively saying. Size of the figure, like I was telling, attributes, height and width you can mention, but sometimes you are not sure how to scale it, because see, one axis you can scale it, other axis you are not sure what will be the repercussions. Like I was telling you, you may change the nature of the figure. A circle may become oval. So then better to use the keep aspect ratio. So then it will take care of the width part. Height you mentioned, width, corresponding width it will adjust. That is always better. Say keep aspect ratio. In the figures, right, like I was telling, you can also have some equation symbols, but use the dollar at the beginning and end, use the dollar symbols. And the space also, as I said, you can adjust in the figures also between the captions, negative or positive, you can still use that, and give the labels because they are referred in the text. You can also have sub-figures, means right, like subsections. You can also have sub-figures. Caption also, every sub-figure also can have captions, or only one caption will be there, sub-figures will be there. All possibilities are there. So how to divide that? Sub-figures is a, right, when you do that, there is a command you can see, sub-figure, begin figure, then you say sub-figure. You can have multiple, see, the labels because you are referring them, and then you can also have a caption for that, a common caption. It is your choice. Space between the figures you can adjust by vertical space, right, like those commands, is the positive side or negative side. So in short, right, it's not that I have given a valuable inputs. Whatever is the minimum knowledge is required, I try to discuss in this presentation. But however, you can always find it on the internet. Good number of books are available, maybe a better videos are available. You can go through them, learn it, lifelong they are useful because it's a language. By using a proper language, right, you can have a better attributes, better way of representing your technical documents. Software is free, open source tools, but however, if you use the proper commands, then only it will convert it to the appropriate document. And then I said types of documents you are supposed to create. That's the beauty of the programming. Lot of information is available in the public domain about the LaTeX command summary. This is command summary. As you can see, once you put a backslash, after that whatever you type is a command. Like math mode alpha, if you want, then say /alpha, then alpha symbol will appear, and so on, like that. See, we already seen begin equation, begin figure, begin center, begin enumerate, equation array, begin equation. These are all the commands, right? You can refer them based on your requirement. At the end, you will find even the math symbols. You can see if you want in Roman, if you want italic, bold, BF is bold font, right? Miscellaneous symbols, there is a commands for them. Okay, like Greek letters, alpha, beta, gamma, delta, whatever you want, you can put /alpha, beta, gamma, then that symbol will appear. And the math modes, binary operators, everything is a command. Okay, arrows, miscellaneous symbols, and so on. So it's a manual. One can refer the command summary manual. It's not big. We don't need all of them also. Whichever is required, you can quickly refer that, those symbols. Otherwise, commands are very frequently used. Commands are very few, which are already given through my presentation. I believe that's enough to create your own document. But based on your research, if you require some other features, some other math functions, you can always refer the manual, include them, compile them. It will create a PDF file. So that's all about the LaTeX, and already described in my previous video how to use LaTeX. This video is just to understand where to refer about the LaTeX.
Let us see some more tools, open source tools, like we already seen LaTeX, we have seen editor, gedit. We will see the two more useful tools. There are many more out there, but frequently used tools for researchers. That is Xmgrace and Xfig. Xmgrace is for data plotting, data visualization, data analysis. Skydavis is also there for the same purpose. Xfig is to draw the figures. So let's see how they will work. When you open the software, this is your workspace. You can see your coordinates, x and y axis. Accordingly, you scale your figures. Of course, you can again do the aspect ratio in your LaTeX. That thing is there, but still organize your diagrams. What is the diagram you want to draw? Do you want to draw some symbols, right? You can move them whenever you want. You can copy them. Everything is a mouse click, left button. If you want to delete, you can delete. And like if you want to edit, then you can edit. You can increase the thickness of the lines, dotted, whatever. Once you are done, say apply and done. It's editor. So, or you want to rotate, then you see you can rotate that figure. And if you have some line, if you want to draw some lines, okay, you can draw the line. After that, you can also give the arrow to that lines. Once whatever you want to edit over these things, you can also glue them together, break them, your entire document, whatever you have drawn. So you can use various symbols. You can also include your the provided by the software. Some you can see the charts or some flow chart symbols, right? You can include them in your file, right? all the beauty of pixel, but even grid also you can see the size of the grid you can choose between the pixels. I mean, that's the beauty of this Xfig software. Pixel by pixel you can edit, you can draw the figures, block diagrams, flowcharts, right? And also you can include some pictures. Okay, that's another advantage. Draw some once after selecting the picture, draw the area where you want to have the picture. And what are the types you want to include? EPS, JF, JPEG, whatever you want. You mention, it will filter that this thing. And then you say browse, whatever, if you have already some this thing, inbuilt this thing, take it, apply, close. Okay, now that is part of your figure. You want to scale it, use original scale, scale by something, shrink to original, expand to original. These things you can do scaling your images. Once you are done, this is a EPS file, but once you are done, say apply and done. So that figure will appear. So this you can, like I said, you can change the size also, original size, whatever, if you have any figures. So that's the beauty of Xfig, whatever the diagrams, including the images, right, your own photographs. Like, let me see if I have my own photograph. Browse. Once you are done, what do you want to do? You want to export. So file, first save it. When you save it, right, give some file name. Okay, let's say XYZ, but extension is always .fit. Is the extension. Extension is fit. Say save it. So XYZ.fit is saved. Okay, that's okay, that's figure. But that you cannot include in your LaTeX files, because LaTeX understands you say export, right? When you say export, now you see LaTeX requires encapsulated PostScript, or you see how many types, 10, 12 types are there, JPEG, right? GIF, PNG, or EPS, including PDF, right? PDF also it will be. Here is a PDF file. So now give the file name of your output file, let's say. By default it is XYZ, okay, let it be. So export. That's all. So file you have saved already, exit. Okay, so it has created your this thing. Wherever you have opened the directory, it will save in the directory. Let me see. So we are in 12 before. beauty of this Xfig software, which we are using for several years. Alright, so this is about the Xfig. With the next software we will see called Xmgrace. Xmgrace is the software for data plotting. Okay, you can have the x-axis, y-axis units also. You can mention x-axis units, y-axis units. If you have some data files, right, you should have some data files, and that data file, it will plot it on your screen. And while plotting also, you can also have transformations. You can see the Fourier transformation, histograms, right, interpolation, or some digital filters. So it will apply on your data regression. So this will do those things also, or feature extraction. And then the data analysis, once it has done, the graph will be displayed here. Okay. And then you can also have editing your graph, dividing your graph into multiple these things. Right, you can see arrange graph, set graphs. Okay, now how many columns you want, how many rows you want. For example, I want 2 columns, I want 2 rows. Right, apply and accept. Now you see the entire graph is divided into 4 graphs, 4 subgraphs. And every graph, now what is that I want to plot it, right? You have to import some data and then plot that data here. Then the data will be plotted here. So, and you can also do some ligands, right? All these things can be done. So once that is done, then you say file and save. But this time the extension is .dat, DAT. You have to put the file name. Let's say xyz.dat. Okay, so xyz.dat file is created. But then this is not useful. This is a original file which consists of the data. But what we want is same as JPEG format, PDF format, or EPS format. So again here file, and then you have to say print setup. Right? In print setup, now what is that? Do you want PostScript, or you want EPS, JPEG, something, right? Whichever the format you are interested. Let's say I want JPEG file format. Okay, so it will create xyz.jpg. Then apply and accept. Now go to file and say print. Now it has printed. Your file is not only original file as a .dat file, but it is also printed in an image file format. So where we have saved in the same directory and where we were earlier. That is my files. Then product directory we have there. Now see xyz.jpg file is created, where we have created 4 graphs, and if you have some data will be plotted. Maybe I will type it and show you how to plot the data. And then you can do captions in x-axis, y-axis, all these things, and the transformations on the data. You can apply some spectrum, whatever, histogram, those things can appear. So I hope now these are the 2 useful open source tools we have used extensively, Xmgrace and Xfig. One is for drawing the figures, second is to draw the data and analysis. Third is, anyhow, we have used LaTeX for converting your text files into various file formats for technical documentation and presentations. The another thing is, I have also used this software called Xfig software for recording my video. You can see the Xfig. It is also freeware which is available. You can download simply by typing apt-get in install chasm. So it will give you options, right? When you see now, when you choose these options, general options is which speaker, which microphone you want to select, and then you can also adjust your full volume of microphone and the speaker. Screen casting, how many frames per second you want to record, and then what is the recording style, right? How many, in which file extension you want. Better to use MP4 because other AVA files is a huge amount of data they create. It's a wastage of your hard disk space or pen drives. And the directory where do you want to save it. And this is the by default file name. If you select auto file saving, it will automatically will save. Instead of saving the record video, you can also select for only screenshots. That is also possible. Okay, so this is the software. Once after the settings, then you can see the icon here where it will ask you three options: start recording, pause recording, finish recording. So the moment if I say finish recording, it will terminate and it will save it. If I say pause recording, you can stop it, but you are not terminated. You can still continue it. Start recording is as usual to start recording your contents. So this is again an open source tool for recording your screen, your own presentations. Alright, so that's about the open source tools as far as this session is concerned. I hope you have recalled my previous sessions about the technical contents, technical documents, technical presentations. I will show you one more session which we will speak about the how to prepare the slides in maybe a quick another 5 to 10 minutes. Alright, so let us see how to plot the data. If you have some data files, let's create a data file first. Gedit, I will create one data file. Write some numbers, you type some numbers, whatever you have some random numbers. Now save your data file. Okay, give some file name. Let's say a.dat. Extension should be .dat. Say save it. Okay, now you have saved this data file. Now I want to plot it. The direct way of plotting the data file is Xmgrace and the name of the data file a.dat. Now if you see your data, whatever you type, it has saved, it has plotted. Now you can export that, right? I already said how to save it, how to export those things, you can do it. This is one way of plotting the data. If we have more than one data set, let's say multiple, then let's create that gedit and a.dat. What we do is a few more values we will add, right? Give a space. It will be considered as a new data set. So be careful about the column position because one column represents one data, second column represents second data set. So save it. Now if you want to plot it, okay, grace, same thing, this thing. What it will plot is, right, your whatever the data is there in two columns, separately it will plot. This is one way of doing. Or if you have more than multiple columns, if you can have Xmgrace attribute minus mxy and file name. These are the attributes. Okay, so multiple columns if you have, then you can also say nxy, which n is number, multiple xy axis. This is one way of plotting directly. see, I mean, you can arrange your figure into multiple graphs, and then which data sets you want to take it, you can take it, plot it. Also every graph, again, here you have zoom in and zoom out, those options are there, but you can also have the units, right? You can edit the these things, set your graphs as per your wish, right? Those things are all possible. Okay, so I'm not going by all the features of Grace. You can practice it, or maybe a better videos you can find it in the public domain. So the purpose is just to highlight you that you can use open source tools for your research purpose. So no need of going for commercial tools for this. Alright, so that's all about the open source tools. I'll quickly show you how to prepare the slides. The last topic is, by using LaTeX, how to prepare our own presentation. So far we have seen technical documents, reports, thesis, conference papers, journal papers. Also let us prepare our own presentation, because it's mandatory to give a presentation. But since we have done this, we have used this language for preparation of these reports, why to use again those Microsoft Office for preparing the PowerPoint presentation? Let us use the same scripting language so that your energy is saved. No need of redoing the things. Same as it is, those equations, those figures can be imported. So, how to prepare the slides? I will show you the first how it looks like. So far my presentation is done by using same LaTeX. So if you see the slides, right, my title slide, first logos, everything is there. Even commands are there. First page, go to first page, second page, last page. Commands also possible. Okay, these things. If you use the PDF viewer, then you can see every slides already explained. I can create these slides. Okay. Now these slides, around 12 slides are there, how we have prepared. So there is a first script, like every document has a script which talks about the structure of the document. In presentation also we have a script we have written in show.text file. So here list of commands, document class is article, and some packages are used. Okay, and then some vertical space, because the first page we want differently, and some commands are also I have shown you, those are there, and bottom of the screen the institute name, some affiliation, those things should appear. But finally I didn't write anything here, no slides information, nothing is there except the first slide information. But begin document, end document, this is where I am using only. I didn't even use many files. I said slide file, input slide file. So all my slides are listed in this slide file. So I can comment anytime which slide I want to exclude. So what is slide file? So this is the first is my script. After that, what is slide file consist of? Very simple. Of 12 slides are there. So 12 files I have created. Every slide is one file. I am saying input, all 12 slides. As simple as that. Whenever you want to exclude something, put just a percentage symbol. That particular slide is excluded. That way. Okay. give your dimensions. If you have equations, then say equation set equations. Okay, if you have deleted statements, say items. Same commands, nothing. If you have a mathematical symbols, between two dollars give mathematical symbols, delta, omega, whatever. Now look at the beauty. Now this is called begin, right? Mini page. We said begin, mini page, and mini page. That means my page is divided into two parts. One page is I have given set of equations. Second page may be the program or some image I want to include. So that's why I am saying and symbol. That means now it will go to the second column. Begin mini page. Now this is my second mini page. Item wise I want to display. Now there is a command called ASM code, assembly language code. So now backslash means new lines. This code will appear in a different color. Items and then and itemize, right? Okay, so this is how you can say you can divide your screen into number of sections, subsections. You can have figures, you can have plots, you can have assembly language coding, you can have mathematical expressions. Whatever you have used in your earlier document, same thing is also can be used here. Once you have created the script, you have the list of files, and every file you have created a slide, then the same command you can still use now called PDF, LaTeX, and the original one, show.tx, that is the text file where everything is mentioned. Okay, so if there are any errors are there while typing, still if you want to compile it, simply say run, R for run, it will convert, it will bypass those errors. If you are not by any chance, if some symbols you have wrongly typed, some commands you have wrongly typed, but still you would like to see what is the output file, then you can always say run command. So that's how it is done. Alright, so that's all about the open source tools or some inputs for writing the technical documents. Whatever is possible, I convey. You can still refer to some good authors. I would say this is just a beginning, but lifelong it is useful. Thank you for listening.